In real life, there are many challenges in successfully training a machine learning model. Some examples of such challenges are creating the right features and selecting the right features from the data set. Deciding, for example, on the best option to scale the values of the features, selecting the right algorithm. Just think about it. You have a problem. Say, we go back to the example we've used throughout the course of predicting customer behavior. What is the right algorithm to be used in this particular problem? And the difficulty is that there is always more than a single answer. And then model training involves a process where you need to fine-tune the model hyperparameters. You should regard hyperparameters like components that can tune the behavior of your model, right? Think about them as knobs, and if you move the knob to a different position, you get the same machine learning algorithm, but with a different behavior. So within the same machine learning algorithm, if you set different values for the hyperparameters, you put the knobs in different positions, you get slightly different variations of the same algorithm. So again, the question is, which one of these variations is best suited for the problem? And finally, deciding on which metrics are best to evaluate the performance of your model is again a difficult question. The process of automated machine learning plays on the concept of strength in variety. This is also referred commonly as AutoML, and it is the process of automating the process of machine learning model development. So what it actually does for you, it does the heavy lifting. It trains for you multiple versions of machine learning models where they have different combinations of hyperparameters, different combinations of features, different combinations of algorithms. And that basically allows data scientists, analysts, developers to build such model at scale. And thus it increases the efficiency and the productivity of the machine learning training process. So in a nutshell, automated machine learning explores combinations that help you find the best performing combination to improve the accuracy of your prediction. Now with Azure Machine Learning, it is quite easy to set up an automated machine learning experiment. And by the way, this is a zero-code experience. You can use the features available throughout the user interface to set up your own automated machine learning experiment. So basically, in order to set up the experiment, all you need to have is to have your data set that you want to use for the machine learning training process. And then you need to allocate a set of compute resources to actually run the training job, select the type of task that you want to perform, like classification, regression, forecasting, and then finally select your primary evaluation metric and define what we call a criteria for finishing the process. What is the level of quality at which the entire process should stop? And based on all these inputs, the automated machine learning experiment will find the best performing model. And by the way, in many cases, the best performing model is actually an ensemble model. So this is a great way in which you can see the connection between automated machine learning and ensemble learning. Some of the best models could actually be ensemble learners. So in a nutshell, Azure Machine Learning Studio will make it easy, will make it quick for you to basically train and then register and finally deploy the trained model. What I would like you to remember also is that automated machine learning is not a replacement for the data scientist. The best way in which you should regard automated machine learning is a way to get a baseline, to get that model that has a decent level of performance, and then you should try other approaches as well to get performance that is superior to that created by the baseline model trained by automated machine learning.